Hello everyone, thank you for joining Mauser and Amphenol RF for this webinar, RF antenna solutions for IoT devices and smart technology. My name is Mark Patrick, Director of Technical Content for Mauser Electronics here in EMEA, and representing Amphenol today is Mike Comer, Director of Product Marketing and Business Development at Amphenol RF, and also live with us is Tyler Overton, Product Manager also at Amphenol RF. For those who might not know Mauser, we're a global distributor of the newest semiconductors, passives and connectors for over 1,100 manufacturers. We typically stock around 50,000 products from Amphenol, of which around 4,700 are from Amphenol RF. So if you're inspired by today's webinar, want to investigate their solutions further, we probably have whatever components you need in stock. So just a couple of housekeeping items to mention. So unusually today, I'm actually not at my desk where I'd have excellent bandwidth, but I'm in a hotel room. So hopefully the bandwidth is good enough. It seems to be so far. Also, for logistical reasons today, the presentation section of today's webinar is pre-recorded, but it will be followed by a live Q&A. So please do ask any questions you may have at throughout the presentation using the Q&A button at the bottom of your screen, and we'll answer as many as we can during the live Q&A. If you have any questions around audio or webinar functions, please use the chat function for that, not the Q&A, but the chat function, and someone from the Mauser team will try and help you as soon as possible. So with that, I think, Tyler, you can set the presentation running and we'll get started.
All right. Hi, my name is Mike Comer. I'm the Director of Business Development and Product Marketing with Amphenol RF. Today, I'm going to talk to you about selecting an antenna for IoT applications. The number of IoT devices is growing and in virtually every market. The original acronym was IoT, Internet of Things. But as time went on, more acronyms appeared. IoT for the industrial space, IoMT for the medical space, and I'm sure there will be more to come. One thing's for sure, antennas are a critical part of the RF signal chain in an IoT device. They transmit and receive information to and from other antennas and devices, somewhat like a cable assembly would, if you think about it. RF connectors utilize copper. However, antennas utilize free space and air to transmit data through radio waves. Many of the antennas that are used in IoT applications terminate to popular connectors that we as Amphenol RF sell. Those products could be SMA connectors, RP SMAs, TNC connectors, RP versions as well, and even very, very small connectors like our AMC product or larger form factor product like Type N products for higher power applications. That said, in 2023, this year, we launched a line of various IoT antennas to provide our customers with end-to-end full Amphenol solutions. And this webinar is really designed to provide you, the viewer, with an overview of some basic antenna terminology and an overview of our product offering. Let's start off with some basic terminology. Antenna gain is, as you can read here, the measure of how well an antenna focuses its energy in a particular direction. Here are a couple illustrations, very much oversimplified, that will help to explain how gain can improve an antenna's effectiveness and range. On the left is a directional antenna. As the gain increases, the range increases significantly by many miles, depending on the antenna type and power, of course, but the coverage decreases significantly. The same applies to an omnidirectional antenna, which is shown on the right. As the gain is increased, the cross-section of the radiation pattern thins and elongates. We gain range, but reduce overall coverage. As the gain is increased, the line of sight becomes more and more critical. In the last slide, I provided a couple of very simple radiation pattern examples to help explain antenna gain. The radiation pattern for antennas is critical. For some applications where line of sight with the opposing antenna is available, a directional antenna may be ideal. Other applications may need a more forgiving omnidirectional antenna that offers 360-degree reception. In our specifications, which can be downloaded from our website, amphenolrf.com, we provide radiation patterns for all of our antennas. The XY, YZ, and XZ planes are plotted across a range of frequencies for which the antenna can be used. This information can be used to help select an antenna with the appropriate radiation pattern for your application. The bandwidth or range of frequencies over which an antenna can operate is also important. When selecting an antenna for an IoT application, it's important to understand the range of frequencies that your device will be transmitting and receiving, and selecting the right antenna can help to improve signal fidelity. The antenna shown on this slide is a wideband sub-6 GHz antenna designed to perform well for many applications with frequencies from 6 MHz up to around 6 GHz. If your device will utilize multiple frequency bands within that range, then this might be the ideal antenna for you. If, however, your application requires only a Bluetooth connection, you might find that an antenna with a small bandwidth around 2.4 GHz to be a better solution for you. A smaller bandwidth can also help to avoid interference from other devices and antennas. One other thing to consider is that frequency allocations can change over time and by region. You'll want to be sure that your antenna has sufficient bandwidth. There are many frequency bands used around the world. To simplify the chart on this slide, I focused on some, but not all, commonly used frequency bands and applications. Two lower frequency applications include wireless charging and near-field communication. Wireless charging applications typically require antenna elements that support frequencies below 300 kHz. This low frequency typically utilizes relatively large coils and allows signals to transmit through device packaging. Near-field communication, which powers things like mobile payment systems, operates at 13.56 MHz. This is a global standard, and it provides the optimal balance of range and power efficiency. The ISM band, or Industrial, Scientific, and Medical band, is widely used for many applications as it's designated for unlicensed use. In the US, the 900 MHz up to 915 or so, 2.4 GHz and 5 GHz frequencies are set aside for protocols such as Wi-Fi, Bluetooth, and for applications that utilize these frequency ranges, such as industrial automation, consumer electronics, and scientific research devices. If you have a mobile phone, you're likely familiar with Bluetooth, cellular, Wi-Fi, and GPS. All of these are designed to operate with specific frequency ranges listed above. Amphenol RF offers antennas that will support all of these applications. Antennas can have different electrical geometries. I'm not referring to the actual exterior geometry of the antenna, but the way the conductive elements in the antenna are positioned. Monopole and dipole antennas are very common, and on the outside, they look pretty much the same. Inside, there are a few differences. A monopole antenna has a single radiating element positioned by a ground plane. The ground plane is not needed in a dipole antenna because a dipole antenna has two radiating elements instead. This makes them a little larger in size, typically, than a standard monopole antenna. The radiation patterns are also a little different. A monopole antenna will typically have a more omnidirectional pattern than a dipole antenna, which tends to be a little more directional. Patch antennas used for GPS, GNSS, and RFID applications are flat with a rectangular construction overall. They have a flat metallic patch mounted to a substrate such as fiberglass, ceramic, or other dielectric. Patch antennas are also typically very directional. Another type of antenna that's pretty directional is a helical antenna, which is shaped like a helix or a spring. They're simple in their design and offer a cost-effective solution for simple applications. A coil construction is used on wireless charging and NFC antennas. If you look very closely at the NFC antenna pictured, you may actually be able to see the coiled element there. Now let's discuss the antenna options that Amphenol RF supplies. We offer a full range of external antennas designed to be positioned on the exterior of a device or other structure. External antennas are mostly supplied with monopole or dipole electrical geometries. However, some external antennas utilize patch technology to support GPS, GNSS, and RFID applications. Most of the external antennas we supply are designed to be omnidirectional. External antennas are typically patched as whip or stick antennas. Brick-style antennas with pre-terminated cables are also available. External antennas are available in different lengths, shapes, and sizes. Hinges and swivel options allow the end user to precisely position the antenna to achieve the best reception. Being an RF connector company, we offer external antennas with several different connector options. SMA and RP-SMA connectors are very common in both indoor and outdoor antenna applications. When higher power is needed, Type N connectors, both plugs and jacks, may be found. To integrate an external antenna into a smaller device, a device that's all antenna, an antenna featuring pre-terminated AMC or AMC4 jumpers that connect internally to wireless modules can be used. Finally, for outdoor or wet applications, antennas can be sealed. Standard IP67 antennas allow the antenna to be submerged in 1 meter of water for up to 30 minutes and still function. Custom sealed solutions can be developed for harsher environments. Sometimes an external antenna isn't wanted, maybe for aesthetic or other reasons. A popular type of antenna that can be mounted internally inside a device is an FPC antenna. FPC stands for Flexible Printed Circuit. In this type of antenna, the antenna elements are printed on a flexible substrate. This flexible substrate allows FPC antennas to be positioned inside devices in places that other, more rigid antennas don't fit. An example might be on the inside of a curved enclosure. Using supplied adhesive tape, the antenna can be mounted to the curved structure, and the pre-terminated AMC or AMC4 jumper can be connected to a wireless module within the device. The antennas also have a very low profile and are lightweight. FPC antennas can support a wide range of frequencies and are available in single band as well as multi-band designs. GPS, GNSS, and RFID antennas often utilize patch antenna designs. As I mentioned previously, patch antennas are directional in nature. We offer active and passive patch antennas. The active antennas feature an LNA, or low noise amplifier, designed to reduce noise and improve the overall sensitivity of the antenna. Passive patch antennas do not include this feature. In terms of connectorization, active patch antennas are connectorized with AMC connectors, while the passive antennas feature an easy-to-mount pin connector that terminates to a printed circuit board. Embedded chip antennas are designed to be directly mounted to a printed circuit board embedded inside a device and are ideal for compact electronic devices such as wearables and mobile computing equipment. Chip antennas are available in single and multi-band designs, with multi-band designs offering a broader frequency range. There are several advantages to chip antennas. These include their compact size and lightweight design, the fact that they directly terminate to the printed circuit board, removing the cost of a connector and possible cable. This can make them a cost-effective solution. And by nature, most chip antennas are omnidirectional. And that's great for most IoT applications. But if you're looking for a directional solution, chip antennas may not be the right choice. Disadvantages of chip antennas include limited range versus external or FPC, PCB antennas, Sensitivity to other components on the printed circuit board or the PCB itself can introduce noise into the application. And then I already mentioned the directional limitations. Like I said, if you need a directional antenna for your application, a chip antenna is probably not the best solution. So in summary, Amphenol RF supports the design and development of IoT devices from the printed circuit board all the way to the antenna. Whether you need an antenna that mounts to the printed circuit board itself, or you need to connect your external antenna through a cable assembly to a wireless module, we're here to support your needs. We offer external, internal, and embedded antennas supporting all wireless standards. We talked about that earlier in the presentation. IP-rated antennas are also available for outdoor or wet applications. As I mentioned before, IP67 antennas will support being submerged in 1 meter of water for 30 minutes. Our standard off-the-shelf solutions are available from distributor inventory. And lastly, custom antennas are also available. So feel free to reach out with any questions, and thank you for your time today.
So that's the presentation from Mike. We'll move on to the Q&A. I've got a couple of questions that have come in, and also a few other things to highlight. On the questions from the audience, then Tyler, a couple of things. I don't know if you had a quick look at them, but first of all, there was actually there's quite a few coming in. So we started off with actually a product suggestion. If we could recommend a small antenna for a 4G plus application that is rugged for marine deployed sensors, and it should be connected to an Arduino MKR or Maker 1500. I'm not sure what I do know that board, but I'm not sure. Can't remember what the connector type is on there. The fact that the attendees mentioned marine environment makes me think immediately of the sort of IP67. It's going to need to be something rugged. It's a harsh environment, and I guess beyond that, there are probably other application requirements to consider. So, as with all of these questions, I think we'll come back. What happens, just for everybody who's attending, is the questions will be answered in writing and shared with everybody. So we'll do that over the next couple of days. So I don't know if you have any thoughts on that one now, Tyler, or if we should come back in writing.
I definitely think we could have something for that. I would need to check into, exactly what they need, compare it to, exactly what we have. But I know we have, antennas that are capable of supporting 4G, and I know we have ones that are IP67 rated. It would just be finding the specific one that would work for them, frequency-wise, anything else, size-wise, if they have any requirements there.
Yeah, I think it's a conversation needed, as with all of these kind of questions, isn't there, to understand a little bit more about the application.
Yeah, because a lot of the applications, would have pretty specific requirements. Some don't. Some are, they need a Wi-Fi antenna. There's a lot of options, but typically, I would need to look into the frequency range of each antenna. The applications of it, if how it's rated, everything like that. So I can definitely find you an answer for that. And if not, if we don't have one, then I apologize, but I'll definitely find out one way or the other.
Yeah, sounds good. A couple of others that have come in then. So, and this may be, again, I think some of these we're going to have to dig into, because this one is quite deep, I think. What environment have you assumed for FPC antennas as the dielectric the antenna is placed on impacts the antenna characteristics?
That is a very good question that I'm going to need to talk to one of our engineers about, just to kind of see, what we have on that.
Okay.
Sorry, I don't have that right now.
So that's so Melanie will come back to you with I've got a couple of questions actually. We'll come back to you with a bit more depth on that one, and have have you included the influence of the PCB dimensions on your chip antenna in the data sheet? I haven't looked at the data sheets for chip antennas for a while, but I would assume so.
Yeah, I believe so. So now they were talking about okay, yeah, I believe so. I'd need to check the specific data sheets, and if you have one specifically that you want me to look into and verify, I can. But I do believe so overall. Yes.
Yeah. Yeah. So if you've got for the person who's asked that question, if you've got a specific antenna in mind, then just please drop it in the Q&A so we can come back to you with a specific answer for you. And then also, let's see if I can. Looks like this question isn't complete, actually. Let me just have a look. Using FPC antennas, are tables showing the antenna performance versus material adhered to? Oh, okay. Do we have tables that show the antenna performance versus the material it's been adhered to? I think is the.
So I don't believe that any of those kind of tables are on the data sheets or anything that we've put out publicly yet, but I can see if I have that somewhere else. Maybe I have to reach out to, you have to reach out to someone to see if they have it. Sometimes we do have a little bit of data that isn't, sent out with the data sheets and stuff, but I haven't seen it, but I can definitely check into it.
Okay, yeah. Again, it's somebody called Fleming. So Fleming, if you have a particular part in mind, or if you're just asking generally, then, but if you do have a part in mind, then please let us know in the Q&A. And what about, this is a good one, about impedance matching components?
So if you're talking about like connectors that would connect to the antenna and then cables, cable assemblies, yes, we do have those. It would depend on which antenna you want, but we have 50 ohm, 75 ohm connectors and cable assemblies that you can use. And then, from there, it would just depend on what the antenna has as a connector on the end of it. So if it has an SMA, you would need to find an SMA, or if that's an N type, you need to find an N type. But yeah, we definitely do have connectors to match the impedance of the antennas.
Yeah.
There might be some that we don't, but mostly, yes.
Right. Right. Okay. Yeah, that sounds like typical solution, really, doesn't it? There's another like selection question as well, like somebody looking for a recommendation. And can you please suggest an antenna that works well in BLE band in a test enclosure with 16 DUT at distances from 5 centimeters to 20 centimeters from the antenna? Thank you. So quite specific, I think, and I imagine we'll need to come do a little bit of research and come back about that one.
Yeah, definitely. I don't know, everything about all the parts, right off the top of my head. I need to, go look through the data sheet to make sure of everything. But, I'm sure we can find something that will, work for you.
More product recommendations as well. What's the best small antenna for Wi-Fi extension of a Raspberry Pi 3? Looking for range rather than it needing to be omnidirectional.
Okay, so just a single direction range antenna. I'm gonna pretty much any question looking for a specific antenna for a specific application, I'm gonna need to kind of come back to. But
Yep.
I'll make sure I keep all these written down.
Also, I guess for this Pi 3 question, then it depends what Wi-Fi they want to connect to. Whether it's just 2.4 and 5, 2.4, 5 and 6 gig. So, but that's from Simon. We can help with that, I think.
Yeah, definitely.
And then another one on IP rating, I guess. What IP protection must the antenna have to resist oil vapors in a mechanical industry? Oh, I don't know the IP ratings off the top of my head.
I'm not too sure about that. I do know we don't specifically test with oil, at least to my knowledge. It's submerged in water 1 meter for 30 minutes for our IP67 ones. I'm it would probably depend on the kind of oil. But again, we also don't test for that specifically, so it'd be kind of hard to guarantee you, yes, these will be protected against oil.
Yeah.
My best guess would be yes, they will be. If they're going to be protected against water for 30 minutes, I think they would be protected against some oil. But there could be other things that I'm not thinking of. About the oil that could cause other problems.
It depends on the nature of the contaminant, I guess, doesn't it? In this instance, as ever, I think a deeper conversation about the application scenario is needed. But so that's from Arnaldo. If you've got any more info, Arnaldo, then please do drop it into the Q&A. Related to the marine application question, what should I consider when mounting a 4G device on a steel construction? Generally, how does the mounting affect the performance of the device? I guess that's the interaction between the metallic nature of the construction that the wireless node is mounted on. Mm-hmm. What impact could that have on antenna performance?
So if I'm thinking of this correctly, I'm thinking of an external antenna basically coming out of a steel box. I mean, it might look different, but it shouldn't have any direct impact on the performance. That might change if it's a thick steel box and you put the antenna inside of it, completely surrounded by steel. But if it just happens to be steel as the material, I haven't seen anything specifically that would change anything. You'd have all the normal stuff that steel does in the marine environment, potential corrosion or anything like that. But as far as the antenna performance, I can't really think of anything that would cause it to change the performance unless it was specifically enclosed fully in a steel box.
Right. Okay. He's just asking generally, how does mounting affect the performance of the device? I suppose there's another question there as well, Tyler, which is when you're looking for things like design guidelines and guidance on antenna mounting or positioning or whatever, does Amphenol provide a suite of information on that kind of those kind of topics?
Yeah, so we usually like to kind of provide on a case-by-case basis. So anything that has a panel mounting feature, whether it be a connector or an antenna, we'll try to put as much information on there as we can, whether it's torque specs, the size of the panel that it's meant to go into, or anything like that. But I'm not sure what specific kind of information you'd be looking for.
Right. Yeah, as you say, it's often it's application specific, isn't it? Here's a good application coming up. And again, I think that I know the answer is going to be you'd need to do some research. I suspect this might be a coil antenna. It's going to need to be something flexible. See that about the
install issue? Yeah, that would be my guess. I would believe it would be a coil antenna. Specifically, I can get into that. I can look into that a little bit more and see if there's any kind of specific recommendation we have to look into the mechanical specs that we test them to.
Yeah.
See if there's anything that specifically calls out kind of flexing the entire antenna a certain number of times. I don't remember that off the top of my head. I do know that if antennas have hinges or anything like specific mechanical features, we do specifically test those. But I'll definitely have to look back of someone that could be inserted into a shoe.
That would need some field testing, I think, wouldn't it? Some field trials, literally, because you're going to bury it inside the insole, I guess, mold it so the insole's molded around the antenna and the whatever sensors and electronics are in there. So there's a whole world of mechanical stress and strain on something like that. But certainly, I think looking at the form factors, coil antenna would seem to be the right way to go with that.
Mm-hmm.
Next one is, it was said that the patch antenna type used for GPS application is highly directional. What type of antenna could be used for mobile applications where the antenna might not always be pointing up to the sky?
That's a good question. I do believe that, you should probably be using one of our embedded types of antennas. Um, I'm not too sure though, specifically for that, because let me get back to you on that one. And I might be able to give a more specific recommendation to say, hey, this is one specifically designed for something like that.
What about magnetic antennas, Tyler? Amphenol, I don't know if they mean magnetic base, like you might see on the top of a vehicle, or
So right now we don't sell any antennas that are, magnetic base antennas, so, sticking the antenna to something. That could be something that, potential custom solution with antennas. I'd have to talk to a few people about, whether that's like possible or not. Not sure, if there was any other meeting to that or any other clarification, but if you're looking for something that kind of just sticks onto something metal, we know, no, we do not have that.
right. Okay. There's again, I think there's a lot of application questions here. Can you recommend an antenna for X, Y, or Z? So in the interest of time, I'm going to skip over those, but we will come back with those in writing. Looking at the sheer volume of questions, I just want to put a little caveat out there that it might take us a little longer than we would normally take to come back with all the answers here. So it might take us a few days. We'd expect really to give our written answers back within a couple of days, but I can see there's quite a bit of work to do here. But we'll come back to you all in writing. And I just wanted to come back on the impedance matching question, because where's that gone? Because it was and this, I think this is kind of what I had in mind too, that the person asking the question was thinking more of the sort of LCR networks that you would have to match the board to the antenna, rather than the connector types themselves and the impedance rating of the connectors. So matching networks, I guess, is, you might describe it as whether Amphenol provides that at a component level, a modular component level.
So right now we just have the antennas themselves. We don't have kind of really many, any other components kind of going off of them or anything.
Right.
So I don't know if that answers your question or not. I can definitely highlight that one as a, one to come back to, as well as the recommendations for specific antennas.
Right. Yeah, I think it's because Amphenol is more on the interconnect side and antenna side, right?
Yeah, especially Amphenol RF. We specifically do RF connectors, and now we're getting into antennas. Just worked well with us. We make the connectors and the cable assemblies that connect to the antennas, and so that works with us too. But we don't do a lot of actual stuff to do with the actual boards or anything like that.
Right. What else have we got here? Yeah, so this is the kind of information that I imagine that Amphenol have got somewhere, and it's really the design rules, the recommendations for chip, FPCs, information on placement, environment, metal nearby, PCB dimensions, etc. So there's a set of recommendations that I think, design guidelines, if you will, that would be useful. What does Amphenol have in terms of documentation around that?
I'm sorry, could you repeat the question?
I
was reading it differently.
Yeah, sorry, I've scrolled down quite a bit now in the questions, because we're up to 31 questions now, which is amazing. So thank you to everybody for putting the questions in.
Yeah.
Let me just see if I can find it again. Again, it's design recommendations, really. Just give me a second. And I can't find it. Where's it gone? No, gonna have to come back to it, I think. Gonna have to come back to that one. So we've done patch antennas. There's another question there for a recommendation. Another one, can you suggest a small antenna to help achieve 10 kilometers range at 868 meg? Yeah, we'll come back to that. Offer a service to adapt the RF antennas, e.g. for LTE applications, to the corresponding modem with a matching network and do performance test afterwards. So I guess it's almost like a design consultancy service and testing service there. Does
We
Amphenol
currently
offer anything like
don't
that?
have anything specifically like that. We do offer custom solutions, if that seems to be similar, where you would work with one of our applications engineers to talk about what you need, and then we would see one, if we have the capability of doing it.
Yeah.
And they put together designs for you, and you would work with them. That's technically a separate team from me. I make the products that go through our distributors and get sold, off the shelf to everyone. But we do have services where we can do custom solutions. Yes.
How does the customer access those services then, Tyler?
You can reach out to me and I'll send you to the right person. We just have different people responsible for different regions and all that kind of stuff. So
Okay.
I need to
Yeah.
see who to send you to specifically based on that.
Yeah, depending on where they are, I guess. So what we'll do then is on the Q&A, on the written Q&A answers, we'll include some contact details so everybody will know where to go to get some of these questions answered. We will be coming back anyway with, like I said, written answers. Oh, there's that question again. Found it from Melanie. Have I got that right? Melanie Klenner. What may be meant? What he meant? Oh, sorry. What he may be meant with the design rules for chip and FPC's information on placement, environment, metal nearby, PCB dimensions, etc. So a set of recommendations, essentially. So I can imagine Amphenol providing documentation on that kind of thing.
Yeah, and that would be antenna specific. Some of that kind of stuff is on the data sheet. Some of it, if you have a specific question about a specific material or anything like that, you could reach out to me and I'll find you guys, that answer. But yeah, I don't have all of the antennas, all the information about that, like, laid out right in front of me, ready to, read off everything about, what metals are going to interact with which antenna. But
yeah. Okay. So I think probably a lot of these are application and product specific now. So we've probably answered all the questions that have come in. So I think with that, we can probably wrap up. I can see that a few people have disappeared already. So I guess we've gone through the technical info. We've reviewed all of these questions. We will get back to everybody in writing. So just to wrap up, I'd just like to say thanks again to Mike and Tyler from Amphenol for their time, and thank you to everyone for joining. Questions will be answered in writing, as I've said, and be made available to all participants. So should you wish to watch the webinar again or share it with others, it will also be available on demand. There is a short survey coming up, so we'd be grateful if you could provide some feedback to help us improve future webinars. But with that, I think we can end there. So thanks, Tyler.
all right, thank you guys for having me.
Thanks, everyone. Cheers. Thanks, everyone. Bye.